Hello, welcome to the BMC Learning Series. Today we'll be talking about accessing and using MainView for DB2 through the MainView Explorer. For accessing MainView through the MainView Explorer on my system, I'll enter in the URL bmca.bmc.com:3090/MVE into my browser, and I'll click on Launch MainView Explorer. Then I'll choose Open with Java and click OK. This is the first screen that we'll see when accessing MainView. Here in the tab Plex, you have all the MainView that's installed and operating in your site. And if it's communicating with other sites or companies, you see that here too. In this case, we have BMCA and BMCB, and we can see that they each have their own MainViews. This is the same information, but in another tab called Systems. In this case, I clicked on BMCA and moved down to see only BMCA and all products and targets related to that LPAR. On the left side, click on plus to open the tree. We find BMCA and BMCB. Clicking on BMCA, we find we have 5 DB2 instances being monitored in this LPAR. On the left side, click twice on the DB2 you want to monitor. In the window below, you'll see a menu with a lot of options for monitoring, and on the right there are some indicators about the health of this DB2. To access general information about the MainView PAS, click on the plus BBI info on the left side, then click twice on PAS info view. You will see trace defaults, storage, CPU definition and utilizations, zip time, and so on. Now let's expand the buffer pool group. We click twice on EZDBFRPL view to see the buffer pool menu. Then we'll click twice in overview to display further information. To view BFRPL, this shows the buffer pool statistics. Here you can analyze the buffer pool utilization. We can see that BP0 has the highest utilization. Hence, we might consider spreading the use of BP0 to other buffer pools. Getting back to buffer pool menu view, EZDBFRPL, click on Activity Rates twice. This is an important view for analyzing hit rate, GBP hit ratio, get pages per second, etc. The columns hit rate with prefetch and without prefetch give you insight into how much data has been found in the buffer when queried. In this case, 100% is very good. If you need more information on how we arrive at these numbers, press PF1 over the header of columns to see more details about it. When expanding buffer pool summary, we give special attention to the columns expand, contract, buffer fails, and expand fails. These numbers should always be 0, and if not, the system tuner should seriously consider increasing the size of the virtual buffer pool, because DB2 will have hit many other thresholds which cause poor performance before this occurs. Now on the left side down, expand DB2 stat group and click twice on EZDSTAT to see the statistics menu. This view has hyperlinks to general statistics about DB2. Remember to set Context All to see all your DB2 at once on your next views. For DB2 Activity Overview, click twice on EZDSTAT, then twice on Overview. You'll see the STDB2 view containing statistics about DB2. If any DB2 has a problem, it will appear in Warning Message column. In this case, DB2 DAGA is experiencing a runaway query. Returning to Statistics View menu, click twice on Exceptions. This will show the STEXC view containing all exceptions that DB2 are experiencing now. Again, you can see that DAGA is experiencing a runaway query. Returning to the Statistics View menu, click twice on Activity Rate. Now you'll see that the STRATE view, which contains the activity rates, Pay special attention on the EDM fails row, which gives you information about the number of failures. It should always be 0. Returning to Statistics View again, click twice on Locks. You'll see STLOCK view containing a list of current DB2 locks. Note that the columns deadlocks and timeouts. Deadlocks are caused by threads requesting access to 2 resources which can never be resolved. DB2 chooses its victim by selecting the thread that has done the least number of updates, and lock timeouts are usually caused by an application failing to commit in time for the other thread to gain access to data on pages. Often the problem can be resolved by reducing the time between commits and putting updatable statements near their commit logic. Return to Statistics View menu, EZDSTAT, and click twice on Global Locking. This gives the percentage of global lock contentions for the current recording interval. Now, an interval is a period of time during which data is collected. The time duration of the interval is set at product customization, and the default is 15 minutes. The percentage of global lock contentions is calculated as global suspends divided by total global locks times 100. On your left, expand DDF-CON group and click twice on EZDDF2 to see the DDF Connection View menu. This view has hyperlinks to general information related to DDF. You can see all the threads, server requester, the product's client server, locations TCP/IP and SNA only, and conversations for server and requester. Expanding Lockout and clicking twice on LKBLOCKZ, you'll see that the Lockout blocker plan summary enables you to analyze conflicts and see who is blocking. Clicking twice on LKWAIT, you'll see who is waiting for a resource. LKWAIT shows you the lock timeout type and if it's a timeout or a deadlock. LKBWZ displays the blocker plan name and the waiter plan name, timeout, deadlock, and percentage of conflicts. This information is related to global conflicts. In this case, they both belong to the DB2 DJJ1, but it could be from a different DB2. Here you'll find the object that is causing the conflict. LKCONZ shows the connections that are participating in the lockouts. LSTLOCKZ shows all locks held by threads. Pay special attention to the exclusive locks and in wait columns. This overview, provided by LSOVER, shows us the amount of locks per each DB2, locks waiting, if they are shared or if they are exclusive. Expanding the monitor tree and clicking twice on DM, we'll see the summary for all monitors started by MV for DB2. Some can be started after MVDB2 starts, and others can be started manually online. All these monitors generate warning messages for notification that something is not good and for taking actions using MainView Auto Operator. If you want to start a monitor or see more details about a specific monitor, click twice on SM Start Monitor Requests, then click twice on Num Active. Using Context All, you can see all targets where the checkpoint monitor has been started. Changing the context to DIA1, you'll see the checkpoint monitor only for this DB2, and clicking on it twice will display further details about it. The checkpoint monitor shows us that when the DB2 does more than 4 checkpoints per hour, a notification message will be sent to the journal. The view OBJZ shows us a summary of the status of all objects. In this case, there are some with access restricted. When you click twice on the number under access restricted, you'll see all objects and the type of restriction. You can see all objects in the view OBJLIST and its respective lists of permitted access. All objects connected to MainView can be seen in OPS, PLEXAREA view. Clicking on Kicks Number of Targets, you'll see details about the connections with MainView for Kicks. Here we have MainView for Kicks connections details after expanding the target area summary. Expanding page set EZDPS menu, click twice on Status of Page Set Information. The PSSTAT view shows us general information about all page sets at once. Expanding SQL Cache and clicking twice on SCAPPLZ, you'll see the summarization of dynamic SQL activity by the distributed end-user application transaction name. It can be used to assist in analyzing remote client activity. This is the current traces view. It displays current application traces that are active or complete. It is allowed in target mode only. The row data shows the trace ID, title, trace type, target name, and when the trace was started for active traces. Additional trace information can be seen by scrolling the view to the right. This view is implemented as a hybrid view, where the view header documents the available commands and hyperlinks to ST, start an application trace, HT, display history traces, journal, display PAS journal log, show, view trace options, and so on. After clicking on Big ELAP in the previous view, you'll be transferred to the 3270 view where you can see details about all threads captured by Big ELAP trace. Clicking on any thread recorded in Big ELAP, you can see details about the executed thread. After issuing a PF3, type EZDB2, then enter to see a menu where there's a current traces icon. Put the cursor there and hit enter. Now you see all traces started. Now these two particular traces are started by default when MainView for DB2 starts. You can add more by specifying them on startup params, or interactively start more from here. For starting a trace, issue an ST in the command line and then complete the following view with the desired trace characteristics. Here you can specify DB2 plan. For your detailed trace, you can specify yes for SQL, scans, IO, locks, DDF, DDF VTAM, and change the default values for TR size and TR buff. You can record the trace information in a dataset to be printed. Here you specify to MainView for DB2 what kind of trace you want and the characteristic of the dataset. Now the trace has started capturing the desired information. Once finished with your trace, you can purge it. Just put a P in front of the name of the trace and hit enter. You'll be asked for a confirmation. Say yes, and your trace will be purged. Again, typing context all changes the context from our current DIA1 to all, and now you'll be able to see all the threads active throughout the system in all LPARs that are connected. Here we see all active threads ordered by elapsed time. You can expand the header beneath the title line for navigation assistance. Place the cursor to the left of the title line or on the Show Header field at the right and press Enter. You can close the header in the same manner. The header provides direct hyperlinks to other views, such as alternate forms, like the THD kicks, so that you do not need to return all the way back to a previous menu. And also here are descriptions of the row hyperlinks. These entries identify the header of each column with a hyperlink and a short description of the destination view to remind you of the available options. Getting back to MainView Explorer, expand UTILSTAT, UTLZ, to see all stopped utilities, and click on the number of stopped utilities to see more information about them. This unload is stopped. The lock tuning wizard helps you step through the analysis of lock contention in DB2. either for one subsystem or for a data sharing group. It allows you to look at current status or choose an earlier time interval, perhaps one that a user of your system has complained about. A history of the most important symptoms of lock problems, timeouts and deadlocks, is available, as well as information on system considerations and statistics that can point out potential causes of the problems. Here's an example of where there are a total of 12 locks. You are able to see all locks caused by that thread with detailed information. Expand ZPARM after EZDB2 PARM menu. This menu shows hyperlinks to all DB2 current definitions that are currently running. Click on DB2 definition. Find out the definition you want by scrolling over the cursor. If you're experiencing difficulties or want to go directly to the PARM, click on ZP name C to see all PARMs starting with the letter C, for example. Here you can see the checkpoint frequency defined for this DB2. That's it for today's session. See you next time.